In organic chemistry, we have a simplified way of looking at oxidation and reduction. You've learned the redox principles in 1201 and 1202. The loss of electrons is oxidation and the gain of electrons is reduction. And you had rules for assigning oxidation numbers. You can still go through all that whole way, but it's very long. We have a fast way to do it. What we do is we look at the numbers of hydrogens and the numbers of oxygens, nitrogens, or halogens on the carbon. Here's an example. When methane is transformed to methanol, you can see that the carbon gains an oxygen. So the gain of a heteroatom of oxygen, nitrogen, or halogen, and basically any of the atoms that are more electronegative than carbon, then we have oxidation occurring. So at a glance, we can see that's oxidized. Here we have formaldehyde being changed to methanol. You can see the hydrogen is gaining the carbon is gaining a hydrogen. That's reduction. Here we have ethene being changed to ethane. 2 carbons gain hydrogen. This is reduction. And here we have a carbon losing an oxygen. That's reduction. So to summarize this, what we have is that we look at our hydrogens and the heteroatoms, more electronegative than carbon, attached to the carbon. If the carbon loses a hydrogen or gains oxygen, nitrogen, or a halogen, that carbon was oxidized. However, if the atom loses a heteroatom more electronegative than carbon or gains a hydrogen, well, then you have reduction occurring to that carbon. You go ahead and try it. Is ethanol being changed to acetic acid oxidation, reduction, or neither? Well, if we look, we can see that there is a loss of hydrogen and the oxygen, the number of oxygens are increased. So the carbon is oxidized. If I look at this one, ethanol can be changed to ethene. Is this oxidation, reduction, or neither? Well, you have to be careful because one carbon is gaining a hydrogen, the other is losing an oxygen. One step is reduction, the other one is oxidation. Overall, there's no change in oxidation and reduction.